Hey everyone, today we're going to be going over how to set up a full dev environment with Docker and Kubernetes on Windows. We're going to want to do this so that way we can play around with these powerful tools and learn them over time and get into experimenting with them and also try and make applications that run on these systems. There's a lot to go over, so let's get right into it. Setting up your environment for Windows has never been easier. Microsoft has actually put a lot of effort into ensuring that developing on their system and developing whatever you want is a lot better. Of course, they mostly did this by just kind of taking a Unix system and slapping it into their OS. Before it was accept your fate, you're going to have to deal with the Windows crap, and if you're going to deploy into a Linux-based server, you're going to have to find your own way to develop with it. Or if you're working at some places, you're going to be deploying to a Windows servers. But if you actually look at the statistics of production servers, a very large percentage of those are going to be Linux-based. So you do want to be testing somehow with that. When it comes to developing, you want to keep the disparity between your dev environment and production as small as possible. That minimizes issues down the road when you go to production. It's like, well, it worked on my machine. That is the phrase that is driving our entire discussion today. If it works on my machine, ship your machine because it's Docker. I used to only want to run Linux systems such as like Mint and Ubuntu, but I always found problems when I was trying to work with Windows applications. So if you wanted to use them, you had to find your own way through Linux, which is a pain in the ass, and you're never going to find the right answers because they just don't exist, and you're going to end up pulling out your hair. That is the Linux experience on desktop. The main prerequisite for this entire endeavor today is to make sure that your Windows machine is updated. You want to be on version 2004 or greater than that, because that has all of the features that we are going to enable today and we're going to take advantage of for our own development environment. You can check your Windows version by actually hitting the start button and typing WinVer. And it's actually going to run that as a command into the command line. Hit that, and you're going to see the version up here. It's going to be, right now, I have mine on 2004, OS build 1904, 1.338, but yada, 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 yada. What you're going to do is you're going to go into the Windows Update system settings, and you're just going to keep checking for updates. Keep hitting this button until it's happy, essentially. Even if you get greater than 2004, it's not a problem. Being up to date with your software and security patches is where you should be anyway. So please don't fight me on this. Just go do your updates. Do it now. I'll check later that you've done it. The real question is, why do you want to do this? And like I said, it's a matter of trying to keep the disparity between your development environment and where you're going to be deploying that code, where clients and someone that is external to you is going to be accessing it. By keeping it as minimal as possible, the disparity, you are going to ensure that there is less issues when you deploy. As well, this is a huge boon to your CV and resume, as well as upskilling yourself, because now you know how to work with some of these modern technologies that many companies are now switching over to. And it tells them that you are consistently learning, which is one of the main things that they look for a lot of the times when they are hiring. They're not just looking for someone that has used the technology for the last 10 years. They want to see someone that is able to quickly gain a skill and utilize it. Now, before we go too far, are you updated on Windows? Are you? I'm checking. See? You can see mine. Are you updated? If you are, we need to enable a couple features in Windows through PowerShell. I swear this is going to be the only time you need to run PowerShell. You may need maybe one or two other things, but this is the only main thing you need it for this tutorial. We do have the Windows Subsystem for Linux. That basically is what Windows has done to ensure that development is a little bit easier. They basically just took a Linux box, shoved it onto the OS, and enabled connections to it. And now we're just going to enable that feature for us to use it for our own purposes. So what we're going to do is we're going to run a couple commands that are in the official documentation. You can go into here. I'll have the links for these kind of things in the description, so that way you can quickly access them. But you will actually open up PowerShell as an administrator. If you don't have access to this, you may want to ask whoever does administer your desktop, but if it's your own personal machine, you should have access to this. Otherwise, ask your mommy. So run as administrator, and you'll notice that it comes up with the security thing, which is basically us saying like, yeah, I'm okay with this happening. We can just copy paste. When it comes to commands in the command line, try and make sure you're copy pasting just because it makes your life a little bit easier and you don't have any typos that may break things. So we're going to copy and we're just going to pop into here and go Command V and run it. I already have the feature enabled, so it's not going to really do anything on my side. But you can see the operation was completed successfully. The next one, we're not going to restart though. Typically you would want to restart at this point to actually enable the feature completely. But now we're actually going to upgrade to WSL 2, which is the latest version of WSL with Windows Subsystem for Linux, which enables these features that we're going to take advantage of. The first iteration was fantastic when it came out about 4 or 5 years ago, but they have made improvements on it, especially with consideration to Docker. We'll go down here. We'll see the next command that we want to run. And it's great because you already have the commands here. Just copy, paste, run. Again, it's going to go through. Operation was successful. The next thing, of course, is going to ensure that WSL2 is going to be your default. You just hit copy, you go in here, you go paste, set default version, done. WSL2 is now enabled for any new distribution of Linux that you use. I will be saying distro in the future. That's generally how everything is said with Linux distributions. Now that it's enabled, restart your machine. Then you're actually going to install a distribution of your choice. So we'll go into the store, and if we go search and we go Linux, or if you can't type like I can, it'll still at least come up. And you're going to choose a distribution to use. There are multiple that you can have. You can use Kali, for example, for pen testing. There's Line, which I've never heard of, Ubuntu, OpenSUSE, Debian, Mint, Alpine. I suggest using Ubuntu, whatever the latest is of Ubuntu. It's the easiest for beginners to use, and you don't have to worry about too many of the extra cruft things on the back. But there are plenty that you can choose for yourself once you know a bit more and can play around with. So we'll go Ubuntu 20.04, and you'll install it through here and it'll install and set it up. I already have it installed because I've done this myself. The thing to note too is when you first open this up, you're going to create a username and a password, and that will be your username password for your entire distribution every time that you log into it. If you want to launch your new distribution, you can actually go into the side here, or Windows key, of course, and go Ubuntu, and it'll come up with that distribution that you just installed. So if I click here, it will open up its own terminal with everything that you need for it. So now I have a terminal open with Linux on Windows. No fussing, no mussing. You can play, it's better. Because frankly, if you are working with anything that is development-based, Bash or Z Shell are a lot easier to use than PowerShell or whatever Windows uses in its terminal. If you do run into issues while you're installing, the documentation that I linked to has some troubleshooting at the bottom. I'm not going to go into detail because I just want to make sure that the most cases are covered with the installation. Now that you have Linux installed on your machine, now it's going to get Kubernetes installed. So what you're going to do is you're actually just going to find the installer for Windows and just run that. You don't have to worry too much about it otherwise. It will run everything that's necessary. The only thing that you're going to do is you're going to watch while it's installing, and when it says something about WSL2, you're just going to click enable. It'll ask you at some point, and even if you miss that point, we'll ensure that we do. The older versions of Docker on Windows were notoriously bad because they used something called Hyper-V virtualization, which was not performant. It had a lot of issues, and you couldn't do a lot of the features that are enabled on other versions of Docker. So even though a lot of people can say once you build a Docker image, it can run on anything that has Docker, kind of like the JVM, but better, it's not really true with the Windows case because it's a very different beast, or at least it used to be. Once you have Docker installed, we can also enable it afterwards. So if we go in here and just try and find out where the Docker, the little whale symbol is, click on the whale and go settings. Now that the settings are here, you'll see, of course, directly under general, you are going to see the use WSL2 based engine. Make sure to click that and click apply restart. It's funny because Docker even calls out that WSL2 provides better performance than the legacy Hyper-V backend because it was bad. It was just bad. Once you have that enabled, you've restarted Docker, go into resources and go WSL2 integration. You'll want to make sure you have enable integration on my default WSL distro. I have multiple because I was playing around a little bit, so you can do it on additional ones. But of course, when you enable your default, you only have one to deal with if you're following directly along with this tutorial, so you don't have to worry about it afterwards. And that's it. It's enabled. It's just basically knobs when you start off with Docker and making sure it connects into that Linux system. Now, what this is doing on the back end is instead of having its own little virtual machine, essentially, that it spins up, it's just using the Linux box that's on Windows to run these containers in the back end. But it has them connected in such a way that you can still access them from Windows. But it just gives it the typical environment that it's going to be running with in production anyway. So it makes things easier. Again, so much easier. The next thing that is going to come up here that we'll enable before we move on to developing it directly with remote access is going to be Kubernetes. So it is actually a tab in the settings for Docker. If I click Kubernetes, you can see it automatically has a little thing in here where I just say enable, and you can do show system containers if you want to experiment with the Kubernetes on the system side, but you just click enable, show system containers, and then apply and restart. It's actually going to install all of the command line stuff, essentially, that is necessary to play with Kubernetes. So once you have that restarted, it's going to take a couple minutes for Kubernetes to boot up and be started, but you can check out the status of it on the actual little whale in your toolbox or bin. I forget what this is called. But you can actually see that loading, context, Docker for desktop, but you can tell that it's actually running, and you don't have to worry too much about whether or not it's running, but it's ready. And if I actually go into my terminal for Ubuntu, if I go Docker PS, which is to kind of see all of the running containers, there's a whole bunch of running containers, and these are all related to Kubernetes. Because how Docker's Kubernetes works is it kind of just takes containers and networks them in such a way, and magically, that it creates a cluster. We don't need to really go into depth about what it's really doing. It's a bit beyond this video, and maybe we will talk about it another time. But for right now, you have a cluster on your machine. And as well, you can actually go in here. I'm going to embiggen just a little bit so that way people can see. There we go. We're a little more embiggened now. I can also zoom. But because we have Kubernetes installed, we can actually use the commands to see what's going on. So if I go kubectl git po, it has no resources because I'm in a namespace that doesn't have any resources. But if I do the same command and say -n kubesystem, because I have the system containers available to access, I can see I can see pods running in my cluster. So I can make any command that's necessary. The other thing I suggest you install is something called kubectx. So if you type that into the Google machine or DuckDuckGo, you'll actually see it's just a GitHub repo, but you can actually install this, and it makes working with multiple clusters a lot easier. So you can scroll down, and it shows you what's actually happening here. You can say like kubeNS and kubectx are the two commands that it installs for you. We're going to ignore the installation process other than this one. So these three commands we'll use in order to actually install it on our Ubuntu system. There are some other ways of doing it, but They're a little bit too complicated, and we want this to be as simple as possible. Copy, paste. So if we actually go in here and do that on our base install, we'll actually have that installed and ready to go. So now, because I've already installed it, I can go Kubernetes, and I can see the different namespaces that are available in the cluster. If I go kubectx, there's only 2 contexts that you can access. They're basically the exact same context. It's just given a different name, but you'll get the exact same pods and exact same structure that you would in either one. Now, some real fun comes up by actually integrating this with VS Code, because like I said, Microsoft has taken a lot of strides to ensure that developing is easy, and they've done this with their native code editor, VS Code. So go and download it. If you just type VS Code, it will come up and you can download it. It's a free download, and I'm sure you know how to Google. But we'll open up VS Code. You'll open up VS Code, and you'll notice something a little bit different from mine to yours. You'll actually see down in this bottom left corner here something that says WSL Ubuntu 20.04. And that is because I've actually connected VS Code directly into that Linux box. You'll actually be doing this through an extension called Remote WSL. So I go into my extensions and you go and you search remote. You'll notice this one right here, Remote WSL. And what this does is it connects you remotely into that Linux box and allows you to manage and play and do all your developing in a Linux environment, but in VS Code. So if you are still a little bit timid of doing everything in the command line, you don't need to. Make sure you've installed the extension and then actually pop into the terminal of the WSL in the context of WSL. And if I actually go code dot, so it's a command that actually is accessing the point of which the context of my command line is right now. So if I go code dot, this is going to open up a new VS Code window within the context of my root directory in Linux. And I can edit files here, and it's automatically set up within Linux. So you can see I can go in here and edit files directly. I don't have to fuss and muss. If I go and create a new file, test.txt, I can edit it, hello world, because it always has to be hello world. Oops. Control save, so save it. And if I go in here and cat test.txt, you can actually see that file has been updated in Linux. So you can now develop as if you were developing on a Linux machine and do all your testing and do all your script testing or running as if you were in Ubuntu. As well, we can make Docker files and commands run through Ubuntu as well. So that way you get used to playing and understanding the commands that are going to be necessary for it. So if I, for example, had a Docker file, I could run it in the context of Ubuntu. There we go. We have a full dev environment where we can play around with scripts and Docker and Kubernetes inside the context of a Linux machine, but on our Windows machine. We don't need to fuss, we don't need to muss, and the disparity between development and production is smaller. We don't have to worry about issues when we go into deployment. Now, there are a few other things that you can actually do with remote access with VS Code, but that's going to be something I'm talking about another time. For right now, you've got a basic setup, you're good to go. Thank you for watching. If you liked the video, like it. If you have any feedback or a particular small issue, comment down below and I will try and get back to you. As well, subscribe for more videos. Watch the next video for more fun as well as we learn more about DevOps. If you want to support the channel or you have a larger issue than just a simple comment will do, go to buymeacoffee.com/Neerlo. Link is down in the description and I will try and get back to you, or you can just feed the fiend and give me coffee. For now, that's all. Have a good one.